Hello, welcome. In this short video, let us look at another example illustrating how to calculate the joint PDF condition on an event. So given the following joint PDF, fx, y of x, y is equal to 6 times e power minus of 2x plus 3y for values of x greater than or equal to 0 and y greater than or equal to 0, and the joint PDF is 0 elsewhere. So for this joint PDF, and the event defined as a is equal to x plus y less than or equal to 1, that is, for this event we want to find the joint PDF condition on the event a, which is defined as fx, y given a for condition on a of x, y. We want to find this joint PDF condition on the event a, which is by definition given by fx, y given for condition on a of x, y is equal to the joint PDF fx, y of x, y divided by probability of a. So only thing unknown is the probability of a. Now probability of a is defined as, the general definition is of course the integral of the joint PDF fx, y of x, y dx dy over the area on which the event a is defined. That is, event a is equal to x plus y is less than or equal to 1. So if we calculate the integral over this region, we get the probability of a. Graphically, we can clearly see that the event a is defined in this region. That is, since x and y are, the joint PDF is defined only for positive values of x and y, this is the region of interest, and this is given by x plus y equal to 1. This line is given by x plus y equal to 1, and this is the region of interest. So clearly we can see that the limits of the integration are the value of x changes from 0 to 1 minus y, and that is from this line to this line, and value of x and the value of y changes from 0 to 1. So limits of x are 0 to 1 minus y, that is from here to this line, and values of y are from 0 to 1, and the function the PDF is given by 6 into e power minus of 2x plus 3y dx dy. So this is the integration for probability of a, which is equal to, by separating the x terms, that is integral 0 to 1, by separating the y terms, we have integral 0 to 1, 6 into e power minus 3y integral 0 to 1 minus y e power minus 2x dx dy, and this is equal to 6 into integral 0 to 1 e power minus 3y, and this integration is e power minus 2x into minus 1 by 2, and the limits are 0 to 1 minus y dy. So this is equal to 6 into integral 0 to 1 e power minus 3y, and at x equal to 1 minus y we have e power minus 2 into 1 minus y, and x equal to 0 we have minus 1, and we also have minus 1 by 2 dy. Upon simplification, we have minus 3 into integral 0 to 1 e power minus 2 into e power minus 3y plus 2y, that is e power minus y, and the other term is minus e power minus 3y. So this is the final integration. Continuing with the integration, we have minus 3 into e power minus 2 into e power minus y into minus 1, and we have minus or minus plus e power minus 3y into 1 by 3. And the limits are 0 and 1. This is equal to minus 3 into, at y equal to 1, we have e power minus 2 into e power minus 1 into minus 1 plus 1 by 3 into e power minus 3. At y equal to 0, and this is the second limit, so we have minus or minus plus 2 minus 0 is 2, so you have e power minus 2, and this is equal to minus 1 by 3 into 1. So this can be simplified as, we have e power minus 3 here and e power minus 3 here, so this is minus 1 plus 1 by 3, which is obviously equal to minus 2 by 3. So minus 2 by 3 into minus 3 is plus 2. So we are left with 2 times e power minus 3, and the next term is minus 3 into e power minus 2. Minus 3 into e power minus 2 becomes 3 times minus 3 times e power minus 2, and the final term is minus 3 into minus 1 by 3, which is plus 1. So this is the probability of A. Therefore, probability of A is equal to 2 times e power minus 3 minus 3 times e power minus 2 minus plus 1. Therefore, the joint probability conditioned on event A, that is f x comma y given A of x comma y, is equal to 6 times e power minus of 2x plus 3y divided by our probability of A, that is 2 power e minus 3 minus 3 into e power minus 2 plus 1 for values of x. For values of x greater than or equal to 0 and y greater than or equal to 0, and this is 0 elsewhere. So this is the joint probability density function conditioned on the event A. Thanks for watching.